If you want to figure out the graph of this function, you can follow the following transforming order. First, you need to observe this final transform function. You can find out for this transform function what is the basic function, or we can say what is the parent function or original function. Observe here, this is sine. Compare this expression with the standard form of the transformed function. You will find out this sine is this function, that is the mechanism. So we can find out the basic function. It should be y equals sin x. Then you need to compare this expression with the standard form of the transform function. You can figure out this is a, this is k, a, k, this is d, this is c. So we figure out a equals 4, k equals 3, here minus d, here minus 60 degrees. So we figure out d equals 60 degrees, plus c, here it is minus 1, so we can think it like this, plus minus 1, so c equals negative 1. You need to know when we transform this parent function to the final transformed function, we need to follow the specific transforming orders. That is to say, the transformation according to these two parameters must be performed before the transformations according to these two parameters. So you can figure out these transforming orders, all right? This is the basic function. This is the starting point. According to parameter a equal to 4, we can figure out this transform function. Then according to this parameter k, we can figure out this transformed function. Of course, you can reverse the transforming order between this parameter and this parameter. It doesn't matter. But these transformations according to these two parameters must be performed before the transformations according to these two parameters. Of course, you can reverse the transforming order between this parameter and this parameter. If you have figured out this transform function, you can transform this function according to this parameter d. You will figure out this transformed function. For the last step, you need to transform this function according to this parameter c. It will be the final transformed function, that is the given function. Okay. For this original function, you know, in the Cartesian plane over one period, the one cycle should be like this. That is to say, we can figure out the 5 critical points on the original function. Of course, we just pick up the one cycle over one period as an example. You know, for the sinusoidal function, we can extend the graph in 2 directions. It should be continuous. Okay, there are 5 critical points. That you say this point, it should be this point. This point, it should be 90 degrees, comma 1. This point should be this point. This point should be this point. This point should be this point. If you follow the whole transforming process, you can figure out the corresponding image point for every original point on the original function, on every transformed function, respectively. That is to say, for this function, if you want to transform this function to this function, you need to keep the x-coordinate unchanged. You just need to use 4 to multiply this y-coordinate. So this point will be this point on this transformed function. After this, you need to guarantee y-coordinate unchanged, but you need to reduce this x-coordinate by 1/3 factor. That is 1/k. Here k is 3. So this x-coordinate should be divided by 3. It will be 0 degree. So this point should be the image point of this point on this transform function. After this, we need to figure out its image point on this transform function. For this function, every y-coordinate should be kept unchanged. You just need to move this x-coordinate to the right by 60 degrees, because here it is d, it should be positive 60 degrees. So you need to transform or translate this point to the right side by 60 degrees. That is, y-coordinate will be unchanged. After this, you want to figure out this point's image point on this final transform function. Comparing this function and this function, you will find out the x-coordinate should be kept unchanged. You just need to move the y-coordinate downwards by 1 unit. -1 means moving downwards by 1 unit. So this point will be moved downwards by 1 unit. So x-coordinate will be the same, but y-coordinate will be -1. For every point on the original function, you need to follow the same transforming order. Then you will find every image point on the final transform function. That is, say, this point, its image point should be this point. This point, the image point should be this point. This point, its image point. This point, its image point. This point, its image point. These points are the original points on the original or parent function. These points are the image points on the transformed function. Then you need to locate every image points in the same Cartesian plane. So this point should be here. This point should be here. We use A, B, C, point C, D, point D, E to represent the corresponding image point. Then you just need to connect every point one by one. You will figure out the graph for this transform function. But you need to know this point to this point, the x-slope should be here. It is 60 degrees. This point, it is 180 degrees. So this distance should be 120 degrees. You know here this is K3, so you can use this calculation to figure out the period for the transform function. It is just this distance. It is 120 degrees. Then you will figure out the graph of the transform function. Of course, you need to know we can extend the graph in two directions to get the continuous graph for the final transformed function, which is the given function. This is the original function. This is the transformed function.